It's the Bismillahirrahmanirrahim. It's the smart water cooler, in which the fan speed is controlled by using the microcontroller. The fan speed we can reduce, as you can see here. Fan is on and pump is off. In this way, we can reduce the speed of the fan of the water cooler by using the pulse width modulation of the microcontroller. As you can hear, the sound becomes very faint. Sound is very low. This way, microcontroller can control the speed of the fan by using the pulse width modulation. This button let's switch off the power supply, and again on. It will operate with very low speed because its speed has been saved in the EEPROM of the microcontroller. At a time, pulse width modulation and EEPROM has been used in this project. The fan speed can be controlled. This one again restart. This way we can control the speed of the microcontroller, speed of the fan of the water cooler. So let's see the schematic of this project. Here we can see in the schematic diagram smart water cooler, in which we are using the EEPROM and the timer 0 as a pulse width modulation. A regulator IC7805 has been used to reduce the voltage from 12 volt to 5 volt. This is the PIC 16F2629 microcontroller, which has 8 pins. 2 pins for the power supply, one is the VDD, other is the VSS, and this master clear up is attached to the 5 volt with 10 kilo ohm resistor, and this one is the push button to change the speed of the fan by using the pulse width modulation, changing the duty cycle of the spin, the fan. This fan is attached to the fan. Here the transistor, this way. Here you can see this fan is attached to the with 10 kilo ohm with transistor BDX54C, and by changing the frequency of the pulse width modulation, we can control the speed of the fan this way. When duty cycle is the 50, then speed will be half. If the duty cycle is 100, then it will be operated very high speed. If the duty cycle is 0, then the fan will be off, although the power is on, but the fan will be off due to duty cycle is 0%. And this is the second pin. This pin is attached to the pump transistor. Here you can see the pump transistor. This pump transistor, this water pump, which suck the water from the water reservoir and spray on the walls of the water cooler. It also operates at 12 volts. 10 kilo ohm resistor has been attached. And the next wire, these two wires are used for the water sensing. If there is water inside the reservoir, water pump will operate, otherwise it will not operate. So now let's, and this is the PIC12F629 has been used, and transistor BTX54C, which is about maximum 4 ampere can be passed through this transistor. It needs a heat sink. So let's look the video what happens, and we will see inside of the transistor, inside of the smart water cooler. After that we will learn observe the C codes written for this project. First, water cooler is at high speed. As noise is loud, it means its speed is also high, as you can hear easily. After that, fan is off and water pump is on. Just for 2 to 3 seconds, pump becomes on, then again becomes off. When the pump is off, fan will be on. The pump does not control. This button is used to change the speed of the fan. Pulse width modulation is used. This way, keep on press this button, push button. The speed will gradually decreases. As you can hear the sound, as the sound is decreasing, it means speed is also decreasing. Now it is at very low speed. Duty cycle is about 2 to 3%. This way we can change the speed. Again push this push button, it becomes off. This one, push it. No, it will become 0 duty cycle, 0% duty cycle. Again cycle will start. Again it will high speed about 100% duty cycle. This button is to switch on and off the fan manually, and this button is for water pump, and this push button is to change the speed of the fan, this one, which has been embedded inside the smart water cooler. Speed is gradually decreasing. We have keep on press the push button. This way, now it is with very low speed. This speed has been stored in EEPROM of the microcontroller. If we restart the system this way, it will operate at very low speed, at the given speed. This one, LED becomes off, no, LED is on. This way, it will operate at the same given speed which has been stored in the EEPROM of the microcontroller. Again, restart. It will operate at very low speed which has been stored in EEPROM of the microcontroller. So let's look inside it. This is the inner side of the microcontroller. This one is the transistor which control the speed of the fan with the heatsink. This is the microcontroller regulator IC. This transistor is used for water pump, and this one is the resistor. Power cable has been used. This wire is for water sensing. It will sense the water. And this upper wire is for push button to change the pulse width modulation. This wire is pulse width modulation. This wire is for water testing, to test the water inside the reservoir, water reservoir. Capacitor has been used to remove the noise of the fan. Pulse width modulation, about 3000 microfarad has been used. So this is the system embedded inside the water cooler. Now how to write C code for it? As we are using PIC16F629, we are using this microcontroller, baseline microcontroller. First we are using the MPLAB X IDE free software from the microchip company. We have to first configure this one. If you don't understand this one, you have to visit my channel DCCCPN for the basic of the programming for PIC microcontroller. You have to set the cluster frequency and defining the switch is for pulse width modulation. This is the water pump attached to the GP1. They are the general purpose pins, and test is used to test the water if there is water inside the water reservoir or not. We are initializing some variables this way. Then we are making a function. We have made a function to control the speed of the fan, and interrupt timer 0 has been used as a pulse width modulation. So the codes are quite complex, but it needs understanding this way. Timer has been used. A clock, watchdog timer, watchdog timer is also used. If we turn on the cooler after 4 hours, it automatically becomes off, and speed gradually decreases itself. After 24 hours, it again restart. The water cooler will again restart. When we start the water cooler, its speed decreasing about 4 to 5 hours. After that, it becomes off. On converting of the 24 hour, it will again restart. These are the main project. We are using the EEPROM, and the initial default value is 00. After that, these are the codes. Sprinkle water sprinkles after each 4 to 5 minutes. If there is no water, and if there is no water, then pump will becomes off 0, otherwise pump becomes 1. Then clear watchdog timer. Then when we select the speed will be EEPROM, right? The speed will be stored in the EEPROM. That's why EEPROM has been used. Then switch function is used for different purposes. For example, for 0 case, you will read the EEPROM data when you start the water cooler. It will get the value from the EEPROM reading. So these are the C codes for the smart water cooler. So thank you for watching our video.